Is this visible?
Yes,
Yes,
sir.
sir, it's
Yes, sir.
visible.
Okay, thank you. So let us quickly recall what we have done in last lecture. So we have started with Maclaurin series expansion of a function, of course, differentiable function. So statement is function is f of x, then you can expand it in powers of x about 0, and it is given by f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash at 0 plus x cube by 3 factorial, then third derivative at 0, and so on. Okay, and then we saw some standard expansion, that means expansion of some standard function. Then we used them to expand some functions like 1 plus x raised to x or under root 1 plus sin x and so on. Okay, and lastly we consider this problem, expansion of tan inverse x, and what we have observed is if you differentiate it, so dy by dx is equal to 1 upon 1 plus x square, and using expansion of 1 upon 1 plus x, that is 1 minus x plus x square minus x cube plus x raised to 4. So in place of x you substitute x square, so this dy by dx will have expansion as 1 minus x square plus x raised to 4 minus x raised to 6 plus x raised to 8 and so on. Okay, now this is expansion of dy by dx, but we want expansion of y, so simply integrate it between the limit 0 to x. Okay, integrate it in the limit 0 to x. So you will have dy by dx ka integration with respect to x is y, and then you integrate term by term, so x minus x cube by 3 plus x raised to 5 by 5 and so on. Okay, so this was the trick. So using similar logic you can use you can find expansion of sine inverse x. So can you tell me how do you find expansion of sine inverse x? Anybody?
Can you repeat the question, sir?
How can you find expansion of sine inverse x? Series expansion of sine inverse x.
So we take the derivative and then square it and then integrate.
But dy by dx square, how will you integrate it? Isn't
So
it?
I meant to say that dy by dx will be 1 upon root of 1 minus x square.
Right.
And then we can factorize 1 minus x square as 1 minus x and 1 plus x and then use the binomial expansion.
Okay. Can't we use direct binomial expansion of 1 minus x square raised to minus half?
Yes, sir.
Yes, sir, we can do.
Okay. So just note down somewhere. So y is equal to sine inverse x, then dy by dx is equal to 1 upon under root 1 minus x square, which is nothing but 1 minus x square raised to minus half. Then expand this using binomial expansion. Okay, we know that 1 plus x raised to n is equal to 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial x cube and so on. Okay, so there is a x, in our case it is minus x square. Okay, and n is minus half. Likewise we expand and then you integrate it between the limit 0 to x. You will get this expansion. Idea is clear?
Yes, sir.
Okay. Any doubt?
No, sir.
All right. Similarly, cos inverse x also. Okay. So moving ahead, let us find out some series expansion using substitution. Okay. We have seen similar problem in nth derivative. Question was find nth derivative of tan inverse under root 1 plus x square minus 1 upon x. Okay. Now question is find the series expansion of or prove that the series expansion of tan inverse under root 1 plus x square minus 1 upon x is 1 by 2 into x minus x cubed by 3 plus x raised to 5 by 5 minus x raised to 7 by 7 and so on. Okay. Of course, the direct expansion is not possible because you can see this function is too much complicated. So we need to simplify it. So for simplification, your substitution is x is equal to tan theta. So if you substitute x is equal to tan theta, you will have 1 plus tan square theta, which is sec square theta under root, it will become sec. So sec theta minus 1 upon tan theta. So if you simplify this, sec theta is nothing but 1 upon cos. So numerator will be 1 minus cos theta and denominator is sin theta. So that cos theta is getting cancelled. So tan inverse 1 minus cos theta upon sin theta, which is if you write numerator as 2 sin square theta by 2 and this sin theta as 2 sin theta by 2 cos theta by 2, 2 sin theta by 2 gets cancelled. So numerator will be sin theta by 2, denominator is cos theta by 2. So tan inverse tan theta by 2, which is simply theta by 2. So theta upon 2, theta is tan inverse x. Okay. So upon 2. So 1 by 2 tan inverse x, and we just now see that 1 by 2 and series expansion of tan inverse x is x minus x cubed by 3 plus x raised to 5 by 5 and so on. Is that clear?
Yes, sir.
Yes, sir.
What about others? Any doubt?
No, sir.
Okay.
No.
Fine. You want to copy this? Please respond.
Yes, sir. 1 minute.
Yes, sir.
Okay.
Can you show the previous page for just 2 seconds?
Is this?
Yes, thank you, sir. Sir, it's done.
Done? Yeah, okay. Finished?
Yes, sir.
Okay. So I think we should go ahead. Second is on similar line. Expand sine inverse 2x upon 1 plus x square in ascending powers of x. Now you can see that if you straight away apply Maclaurin's theorem uh, to this function, it becomes very difficult to find out its derivative. Even first order derivative will be difficult. So trick is you need to do substitution. So target is to get rid of this sine inverse. Okay. So if you substitute x is equal to tan theta, so this 2 tan theta upon 1 plus tan square theta is the standard formula of sine 2 theta. Okay. So sine inverse sine 2 theta, which is nothing but 2 theta, and theta is tan inverse x. Therefore, 2 into expansion of tan inverse x is nothing but x minus x cubed by 3 plus x raised to 5 by 5 and so on. Okay, easy?
Yes, sir.
Okay. Copy it fast. Done?
Yes, sir.
What about others?
Yes, sir.
Yes, sir.
So similarly, uh, this you can do at home as a homework. So x minus x inverse upon x plus x inverse, and outside there is a cos inverse. Okay. So I think we have seen this problem in nth derivative, and the substitution is again tan theta. Okay. So then fourth one is cos inverse 4x cube minus 3x. So substitution is x is equal to cos theta, and you simplify it. Here also sine inverse 3x minus 4x cube, substitution is x is equal to sine theta. See, in this fourth problem, you should know expansion of cos inverse x, and this fifth problem you should know expansion of sine inverse x. Okay, are you getting my point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, I'll share this PDF after this lecture, so you can practice it. The next is expand sec x by Maclaurin's theorem up to x raised to 4. Okay. So x raised to 4 means how many derivative you are supposed to calculate? Yes. You want series expansion up to x raised to 4. So how many derivatives you are expected to calculate?
Sir, 4 derivatives.
4 derivative, right? So as we know that statement of Maclaurin's theorem is f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 plus x cube by 3 factorial into third derivative at 0. fourth derivative at 0 and into x raised to 4 by 4 factorial. So f of x is sec x, so f of 0 is 1. F dash is sec x tan x, so its derivative, its value at 0 is 0 because tan 0 is 0. Then second derivative, so sec x into derivative of tan x is sec square x, so that becomes sec cube, plus this tan x as it is, derivative of sec x is sec x tan x, so this becomes sec x into tan square x, so its value at 0 is 1. Similarly, you calculate third derivative. Okay, so here you will have to apply again product rule, sec x into tan square x, and then its value at 0 is 0. Okay, similarly fourth derivative, and its value at 0 is 5. Okay, so these many derivatives are expected. Then you simply substitute these values in Maclaurin's theorem statement, so it becomes 1 plus x square by 2 plus 5x raised to 4 by 4 factorial, and so on. Okay, so just note it down. Please note it down. See, many MCQs can be formed in series expansion. So find first two terms of sec x, find first two terms of tan square x. Likewise, questions can be formed. Okay, for 1 mark or 2 mark. Done?
Yes, sir.
Others, please respond.
No, sir.
Yes, sir.
Okay.
1 minute, sir. 1 minute.
Okay. Which step you are copying?
Sir, a little bit from the first derivative, sir.
Okay.
Go down, sir, now.
ठीक है?
More, sir.
Hmm?
A little more. Yes, sir. Done, sir.
Okay, fine. So here we come at the end of this Maclaurin series expansion. So before we go to this Taylor series expansion, let me quickly give hints for these three problems. Expand the Maclaurin's expand this function using Maclaurin's theorem. Say x raised to 4 or x raised to 5. In exam, we'll be specifying up to x raised to 4 or x raised to 5. Okay, so you don't have to worry. So can you tell me how do you expand this? Anybody?
So we will take log.
Okay.
So can we do UV method, like we can take e raised to x as u and sec x as v?
Okay. Any other choice? Yes, anybody?
Sir, we'll differentiate e power x sin x and we know that e power x stays the same even no matter how many times you differentiate it. So from there you can move forward.
Okay. Fine. So let me tell you the simpler way. Let us discuss about e raised to x into sec x. Okay. So question is, it's a series expansion. So out of which we know series expansion of e raised to x separately and series expansion of sec x separately. Okay. So you write down both series. Okay. And then multiply them term by term. Okay. If question is up to x raised to 4, then you multiply up to x raised to 4. Is that clear? This is the hint. Any doubt? Of course, you can find out derivatives
sir.
till x raised. You can find out derivatives till x raised to 4 or x raised to 5 if they have asked. But that will take much time, isn't it? So instead of doing that, you use standard expansion of e raised to x and sec x, and you multiply term by term. Pick up first term of e raised to x, multiply to each term of sec x, then plus second term of e raised to x, multiply it to each term of sec x, and so on. Okay, is
So
it
in this
clear?
we will be given like we have to do 2x to the
Yeah,
power 4 or
yeah,
x to the
yeah,
power.
it will be given to you. Okay, for this example, you take it as x raised to 4. Okay, or x raised to 4 or x raised to 5, whatever is applicable. Fine. First is clear.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Similarly, second also, you know standard expansion of e raised to x, then expansion of sin x. You write down those series and you multiply term by term. Okay, and find it up to x raised to 5. Okay. Secondly, our third problem is expansion of log of sec x. Okay. So, yes, any smart answer to this? If you want up to x raised to 4, what will you do? Of course, taking derivative is one of
Sir,
the way.
Yes, sir. After taking derivative, we'll be only left with tan x. So then we can write the series.
Acha, you mean take derivative of log of sec x, first derivative.
Yes, sir.
It is 1 upon sec x. Okay, that will be simpler way in that case. But one more way is write down series of sec x. So what it is? Log of 1 plus x square by 2 plus 5 by 4 factorial x raised to 4. Okay. Log of 1 plus x square by 2 plus 5x raised to 4 by 4 factorial. So what we have is log of 1 plus something. Okay? Log of 1 plus something. Are you getting?
So can
Yes,
you
sir.
repeat?
Yeah. Log of series of sec x is 1 plus x square by 2 plus 5x raised to 4 by 4 factorial. So that means log of 1 plus this whole thing you can treat as a z. Okay, x square by 2 and the next terms you can treat as a z. So log of 1
Yes.
plus z, right?
Yes, sir.
Okay, and then
Yes, sir.
you can use expansion of log of 1 plus z. That is z minus z square by 2 plus z cube by 3 and so on.
Sir, can you repeat? I did not understand.
Okay, fine. Instead of this sec x, write its series expansion. So what it will be? Log of 1 plus x square by 2 plus 5x raised to 4 by 4 factorial. Okay.
Yes, sir.
Now this x square by 2 plus 5x raised to 4 by 4 factorial and so on. This whole term you can consider as z. Okay. Some other variable, say y, z or y. So it becomes log of 1 plus z. Okay. This whole thing is z. Up to this step is it's fine.
Yes, yes, sir.
Okay, so now you know standard expansion of log of 1 plus z.
Yes,
What is
sir.
it? Z minus z square by 2 plus z cube by 3 and so on. And then you re-substitute z. Z was x
Okay,
square
sir.
by 2 and then this term. And you collect the coefficient correctly. That is one way. Understood?
Okay, sir. Yes, sir.
Okay, fine. So with this Maclaurin series expansion ends. Let us quickly start with Taylor series expansion. So any doubt in Maclaurin's theorem expansion?
No, sir.
All right. What about others?
No, sir.
No,
No, sir.
sir.
Okay, fine. So let me
No
stop
problem.
this PDF. So similarly, there is Taylor's theorem defined for the function f of x, but you can expand this function f of x about any point h. Okay, about any point h or about any point a. So statement is, let f of x plus h be any function whose expansion in powers of h is given by f of x plus h is equal to f of x plus h into f dash x plus h square by 2 factorial f double dash at x and so on, h raised to n upon n factorial nth derivative at x. Okay, so condition is this function has to be differentiable, n time differentiable. So this h is not looking good, so let us change role of h and x. Okay, so what it will be, if you replace x by h and h by x, we will get expansion of f of x plus h in powers of x. Okay, if you replace x by h and h by x, you will get expansion of f of x plus h in powers of x. So that is f of h plus x into f dash h plus x square by 3 factorial x square by 2 factorial f double dash at h and so on. Okay, now if you see that if h is equal to 0, if h is equal to 0, then you will have f of x is equal to f of 0 plus x into f dash 0 plus x square by 2 factorial f double dash at 0 and so on. Okay, and what is this? If I substitute h is equal to 0, what will you get?
Maclaurin's expression.
Maclaurin series expansion. Okay. So Maclaurin's theorem is particular case of Taylor's theorem. Maclaurin's theorem is particular case of Taylor's theorem expansion. That is the deduction. Okay. So write down this statement. Instead of writing this first, second one is simpler. Okay. Because it is expansion of function f of x plus h in powers of x. Note that both these statements are same. Okay, just we are replacing variable. I mean, we are renaming variables. Then give a title, Taylor's theorem or Taylor's series expansion. Under that, write down this statement. Copied?
Yes, sir.
Fine. Now, here it is expansion of f of x plus h in powers of x. Okay. But we can find out expansion of f of x in powers of x plus a or x minus a. Okay. So simply write x as x minus a plus a. Okay. In above expansion, x minus a plus a. So f of x will be f of x minus a plus a. Then write x minus a as y and h as a. So this becomes f of y plus h, okay, equal to f of h plus y into f dash h plus y square by 2 factorial f double dash at h plus y cube by 3 factorial third derivative at h and so on. Okay. Then you resubstitute h and y. So h is a. So f of x is equal to f of a plus x minus a into f dash a plus x minus a square upon 2 factorial second derivative at a and so on. Okay. Now what is this? This is series expansion of f of x in powers of x minus a, in powers of x minus a, because you can see that x minus a square, x minus a cube and so on. Okay, understood?
Yes, sir.
Please note it down, because we are going to use this two statement while solving problems. Every time you need to change roles of x and a during example. Copied?
Yes, sir.
Okay. So this is the third point which we discussed. If you substitute h is equal to 0, we'll get Maclaurin series expansion. Okay, so let us discuss first example. So using Taylor's theorem, express x minus 2 raised to 4 minus 3 into x minus 2 cube plus 4 into x minus 2 raised to 2 plus 5 in powers of x. So tell me which deduction you are going to use. This is first and this is second. Read the question carefully and tell me which deduction you are going to use. What is question? Expand x minus 2 raised to 4 minus 3 into x minus 2 cube plus 4 into x minus 2 square plus 5 in powers of x. Tell me.
So the second one in which we will put x minus 2 as the form of x minus a means y, and we value like 3 and all that as x.
But that will be
Or
expansion
like
of
means
that will be expansion of f of x in powers of x minus 2.
so okay, 1 minute.
See, our question is expand this function in powers of x. And the second deduction is expansion of f of x is f of x in powers of x minus a. So you need to understand what is given and what we have asked to find. Yes? Tell me. Do you believe that
We'll have to use,
first deduction? Yes?
yes, first deduction.
Okay. So
F of x minus 2.
So what is given to us? What is given to us? F of x plus h is given to us. And we have asked to find out its expansion in powers of x. Is that clear?
Yes, sir.
Yes, sir.
So what is value of h?
Minus 2.
Minus 2. Good. Okay. So h is minus 2. Tell me f of x. This is f of x plus h. Tell me f of x. You are not audible, I guess. Yes, anybody else? What is f of x in this function? Because we need to find its derivative and its value at minus 2, then second derivative, its value at minus 2, and so on. So tell me, what is f of x in this case? Sorry?
Shouldn't it be x raised to 4 minus 3x cube
Yeah,
plus 4x square plus 5?
good. Okay. See, f of x plus h is given and you want f of x. So you simply subtract h. So f of x plus h minus h. So f of x minus 2 plus 2. So it becomes x raised to 4 minus 3x cube plus 4x square plus 5. That is my f of x. Is that clear to everyone? Please respond because this is important.
No, sir.
See, f of x plus h is given to you. And out of this, you want f of x. That means you want to get rid of this h. Okay, so how will you do that? So f of x plus h minus h. So x minus 2 plus 2. So that becomes x raised to 4 minus 3 into x minus 2 plus 2. So that is x cube and so on. Fine.
Yes, sir. Fine.
Yes, sir.
Please understand this, because you are going to face such a thing in each of the problem in Taylor's theorem. You need to write f of x carefully. Okay. So everybody believe that f of x is x raised to 4 minus 3x cube plus 4x square plus 5.
Yes, sir.
Okay,
Yes, sir.
fine. So we want expansion of f of x plus h in powers of x. So this is the statement. So f of h plus x into f dash h plus x square by 2 factorial into second derivative at h and so on. Okay. So f of x, h raised to 4 minus 3h cube plus 4h square plus 5. Its value at minus 2 is 61. Then derivative is 4h cube minus 9h square plus 8h. Its value at minus 2 is minus 84. Then second derivative is 12h square minus 18h plus 8. Its value at minus 2 is 92. Then third derivative is 24h minus 18. And then its value at minus 2 is minus 66. And at the end, fourth derivative is 24. And its value at minus 2 is also 24. So substitute these coefficients. So 61, here it is minus 84, here it is 92, here minus 66, and here it is 24. Okay, so you will get expansion of f of x minus 2 in powers of x as 61 minus 84x plus 46x square minus 11x cube plus x raised to 4. Okay, any doubt? Please understand this. Yes, any doubt?
No, sir.
Please note this down. Please clear your doubts if any. Finished?
Yes, sir.
Okay, fine. So
Yes, sir.
it's 11:40. Uh, we'll go to the second problem tomorrow. You can note it down, or you can try on your own. Expand 2x cube plus 7x square plus x minus 6 in powers of x minus 2. Okay, you can try on your own, and we'll see it tomorrow. Okay, before leaving, just write down your name and roll number in chat box.
It's written.
Yeah. Then you can leave this meeting. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.